Hi, my name is Edward Fish, and today I'm presenting Rethinking Genre Classification with Fine-Grained Semantic Experts. This is joint work with John Weinbren and Andrew Gilbert from the University of Surrey. So genres are a useful construct for communicating a general overview of the narrative plot and style of a movie. However, in genre and film theory, it is generally accepted that genres are not reliable indicators of a movie's audiovisual semantic content. And we can see here in example 1 that although the three movies share the multi-class label history, biography, and drama, the settings, costumes, themes, and styles vary widely. Furthermore, genres change over time. For example, a horror movie from 1938 looks very different when compared with a film from today, as shown in example 2. In our paper, we show that because of these limitations, genre classification leads to poor results on movie retrieval and recommendation tasks. We argue that researchers conducting genre classification work should rethink how useful genre labels really are for these applications. In contrast, we propose that genre labels should be used as a weak proxy that can be used to complement video retrieval and clustering. To prove this, we train a coarse video encoder on a genre classification task and extract the feature representations. This is shown in image 1. As we can see, the movies are tightly clustered together according to their labels, despite the variation in semantic content. We've then continued to train this network self-supervised, pulling similar movies together, pushing dissimilar movies apart, but still retaining some global genre information. The result is a fine-grained embedding space where tight clusters of genres are broken up into semantically meaningful subgenres. Our contributions are as follows. We present a self-supervised method for generating sublabels from sparsely labeled data. We introduce a new sampling method for contrastive learning of long video segments of up to 3 minutes long. To evaluate our method, we also introduce a new multi-modal movie trailer dataset, MMX Trailer 20, featuring over 8,800 trailers with pre-computed expert embeddings. Our methodology is as follows. First, we use scene detection to split full-length trailers into individual scenes. We then split these scenes into chunks of frames, which are fed through an expert encoder network to extract feature representations. To achieve this, we use pre-trained networks for location, motion, object detection, and audio recognition. After aggregating experts to a common dimension, we fuse the experts using collaborative gating. We show in the paper the reason behind using collaborative gating, as it leads to greater classification results when compared to concatenation and pooling. We also show the influence of each expert for the classification of each genre. Following collaborative gating, we have one feature embedding for each chunk. We then reconstruct the trailer by concatenating the expert feature embeddings for a group of chunks and projecting to a sequence representation. We then repeat with sequences to obtain a trailer representation. This network is then trained for multi-label genre classification using a binary cross entropy loss. So after training the genre classifier, we then continue to fine-tune the model self-supervised, using a contrastive learning method inspired by SimClear with a normalized temperature cross entropy loss. To sample positive and negative pairs for self-supervised learning, we split the trailer into two halves and use the feature representations as a positive pair. To evaluate the effectiveness of our technique, we created the MMX Trailer 20 dataset, comprising of pre-computed expert embeddings for over 8,800 trailers, collected via Apple Movies and YouTube with labels from IMDb. Advancing on current movie trailer datasets, MMX Trailer 20 features up to 6 genre labels per trailer from a possible 20 genres. The dataset also features movie trailers from the 1900s to movies set to be released next year, covering a wide array of styles and periods of cinema which do not feature in current movie trailer datasets. Here we can see some retrieval results for some target trailers. In example 1, Mega Shark vs Giant Octopus, the coarse genre classifier correctly retrieves movie trailers that share the label science fiction, but the content appears dissimilar. After fine-tuning the network self-supervised, the fine-grained retrieval network retrieves movies with the correct label science fiction, but which also feature similar content, including sea monster movies and environmental disaster movies. In example 2, we find that when we run retrieval on a Telugu movie trailer, the coarse network provides accurate romantic comedy movies, but the fine-grained network actually retrieves other Telugu movies. Further examples are available in the paper and the supplementary material. Thanks for watching. The coding dataset will be available using the following link.